Okay, we're going to find out if this sequence here converges or diverges. And this one's super tricky, so if you got this on a test and you'd never seen it before, you probably would not get it. For real, like this one's weird. Especially if you've never done like a change in limits with these sequences before. So what you have to do is notice that we have 1 over n in there, and we can make this into 1 over n also. Then we can make a substitution, just let 1 over n be x. And the reason we're pushed to that corner of trying something so weird and different is because if we try to solve it the way we normally do, just let limit as n approaches infinity, we try that, of course, and what happens? We get infinity, and if we plug in infinity in here, we get sine of 0. Sine of 0 is just 0, so we get infinity times 0. And that doesn't tell you anything. That's not 0, or infinity, or whatever thing you think it might be. It's not. You have to keep trying to find out if it diverges or converges, if you get a multiplication of 0 and infinity. So therefore, let's try to make this into 1 over n. How do you make this into 1 over n? If it's being multiplied, then you would just divide by it. And you would get the same formula, really, just changed in form. This is the same as that. So now we could let 1 over n be x. We're going to let it be x because we notice that this is the same as this. And if we let limit as n approaches infinity of this, we let n go to infinity loose on this n right here, what happens? This approaches 0. So let's plug in infinity right there, and it approaches 0. And that is also approaching 0. So, but we can't leave it like that, right? We can't leave it like that because we're dividing by 0. So we have to change it into x's. We have to change it into x, and say that the limit approaches 0. Now it's no longer n, now it's x approaches 0. So, now that we have this, and the limit should go on this side too. I'm being a little sloppy. If you really want to be like really good, you probably want to put the limit on this side too. So now what do we have? We got sine of x. Sine is approaching 0. This is approaching 0. We could take the derivative of both the top and the derivative of the bottom. This is L'Hopital's rule. L'Hopital's rule is permissible whenever you have infinity over infinity or 0 over 0. And you're taking the limit of that. So here we have cosine of x. That's the derivative. And we've got 1. That's the derivative of x. So we have cosine of x. Cosine of x with the limit as x approaches 0. Plug in 0 into cosine, and you get 1. So our sequence here, does converge. It converges to 1.